Hello and welcome to a tutorial on digital electronics. And today I was just thinking about discussing on demultiplexers a bit. Okay, so for those who have followed our tutorial on multiplexers, you all would just find that the demultiplexer is just an opposite to what a multiplexer is. So basically, in order to define a demultiplexer, I would say that the demultiplexer is a digital device that basically falls under the category of combinational logic circuits. So in any type of digital, any book on digital electronics, you would find the demultiplexer categorized under the combinational logic circuits part. And the demultiplexer, what it basically does is it just distributes the data, okay, a digital data at the input of itself to any one among the many number of output lines that it has. So basically for this reason it's also regarded as a data distributor. Okay, you'll find this reference in some of the books on digital electronics. Okay, so quickly coming to the operation of a demultiplexer. So let's just for the moment consider that this rectangular block that I'm drawing here represents the circuit of a demultiplexer. Okay, just consider this for the moment. Okay, so before I move on to the details of the demultiplexer circuit, I would like to mention two things that are very important. One is that all demultiplexers should have a single input line and must have multiple output lines as well. So every demultiplexer should have a single input line and multiple output lines. Okay, so for this reason we draw a single input line in our multiplexer under discussion. Okay, and the data that we require to distribute in one of the output lines, okay, that data we apply at the input line. As you can see, it is denoted by the letter D. Okay, so I just said the demultiplexer needs to have multiple output lines, but I did not mention, if you just look at it carefully, that how many output lines it should have. Well, then that's a quite obvious question. How many output lines would I draw in this circuit? So in order to answer that question, just assume for the moment that N here represents the number of output lines on the demultiplexer, while M represents the number of selector inputs. Okay, so I think you are coming across this term for the first time, I guess, in this tutorial. So by the term selector inputs, we mean that the demultiplexer has certain other input lines, okay, which are referred to as selector inputs. Okay, so I'll come back to the functioning of the selector inputs in a short while, but just for the moment just consider that based on this information, there's a mathematical relationship that connects the number of selector inputs and the number of output lines. Now that mathematical relation could be summarized as N equals 2 to the power M, which means that the number of the number of output lines is obviously equal to 2 to the power of the number of selector inputs for the demultiplexer. Okay, so basically if we just have let's say 2 selector inputs in the demultiplexer circuit under discussion, then we would get 4 output lines of our demultiplexer. Okay, and if there are, let's say, 3 selector inputs of our demultiplexer, then the number of output lines that it should have would be 8, and if it has 4 it would be 16, and so on. The list goes on endless depending upon the design and the number of output lines that we want. So basically let's say in this example, let's just consider our demultiplexer has 3 selector inputs. Okay, so I draw them over here, selector inputs. This is S0, S1, and this is S2. So basically here, okay, I'll just come back to the details later. And corresponding to 3 selector inputs, we would get 8 output lines. So I'll draw 8 output lines over here again. 1, 2, 3, 4, 5, 6, 7, and 8. So I just named them as Y1, sorry, Y0, Y1, Y2. Oops, there is a little shortage of space. So okay, fine, till Y7. Okay, in order to just avoid cramming up the space a bit, I just did not name all of them. Okay. So now that our demultiplexer circuit is fully drawn, okay, I'd come back to the functioning of what basically the selector lines does. Is that the selector lines helps us to select any particular output line to which we want to transfer the input data to. Alright, so let's say if we just select the line, let's say Y1, then the input data would be transferred to the output line Y1, and we would obtain the data D from the output of Y1 respectively, while the other output lines would just be in their don't care state. Okay, so basically how do we select the required line? Okay, we select the required line by means of supplying an input binary code to the selector lines, and that the input binary code would correspond to the decimal notation of the line 1, which is 1 over here. So as we can see here that our number of selector lines in this demultiplexer circuit is 3. So the the highest number of binary bits that it could hold is 3 bits maximum. So our selector input can hold a binary code of 3 bits maximum. And if let's say we want to select the line Y1, then we would require to input a binary code which is obviously the the binary equivalent of the decimal notation, that is 1 in the case of line Y1. So 1 is represented as 001 in terms of a 3-bit binary code. So therefore, whenever we would apply the code of 001 at the selector inputs, then the line Y1 would get selected, as this code corresponds to its decimal notation, that is 1 in this case. So whenever the line 1 gets selected, the data at the input, that is D, gets transferred to the output of line Y1. And now this at the selector inputs, we see there are 3 types of naming of the 3 different lines, this S0, S1, and S2. So among them, the line S0 of the selector input lines holds the LSB of our binary code input, and the line S2 would hold the MSB of the binary code input to the selector lines. So basically that is basically the type of operation that is performed with the demultiplexer. And now if you all are probably wondering by now that what would the internal circuit of the demultiplexer would look like. Okay, I would answer your question, and in order to do so, I would just show you this diagram. Okay, there it is. So in this diagram, if you just take a close look, you'd see that it says 1 to 8 demultiplexer logic diagram. Okay, one more thing, I just forgot to mention one detail. That is, if we just want to name a demultiplexer, then there's a convention in which we do so. If we just take, for example, the demultiplexer that we had discussed in our example. So our demultiplexer, as you can see, had 8 output lines. Okay, so basically if we want to name our demultiplexer that was under discussion a short while ago, we would name it as 1 to 8 demultiplexer. Okay, so a demultiplexer is also referred to as a demux in short. Okay, so for any kind of demultiplexer that has 8 output lines is named as 1 to 8 demultiplexer, and for other types of demultiplexer that could have 4 output lines, 2 output lines, and 16 output lines also, they would be named as 1 to 4, 1 to 2, and 1 to 16 demultiplexer, and so on. So with that detail, I again come back to our logic diagram of the demultiplexer circuit. So here if you just take a closer look, okay, I would rather use black in this case. So if you just take a closer look right here at this circuit, then this is the logic circuit, okay, constructed by means of logic gates. That is, this is the electronic circuit of the demultiplexer, okay, under discussion. So this too is, as you can see, a 1 to 8 demultiplexer. So there is a single data input, okay, and there are 8 output lines, as you all can see over here. So basically this data that we're supplying over here, that is D, okay, it might be a 0 or a 1, as this data is a binary data. So now depending upon what the case is, if we just want to transfer this data to a particular line, let's say we want to transfer this data to the line Y0, okay. So if we just want to transfer this data to the line Y0, what we would do is that we would just input a binary code of 000 at the selector inputs, okay. So by supplying this input binary code of 000, which is just the binary equivalent of the decimal notation of the line Y0, which is obviously 0 over here. Then by doing so, we would just select the line Y0, and if you'll just take a look at this first line, then the data from the input gets transferred to the output of the line Y0. As you can see, the data appears under line Y0. Now in this case, only line Y0 would output the data D, while the rest of the lines, as you all can see over here, would be in their don't care state, okay. So we just don't know about what outputs the other lines would hold, and it just doesn't matter, okay. Only for the fact that the line Y0 would have the input, the data D at its output. Okay, let's just consider another example. Let's say we just want to select the line Y5 and transfer the data to it respectively. So in order to select the line Y5, we would require an input binary code of 101 at the selector inputs, okay. And now this 101 is obviously the binary equivalent of the decimal notation, that is 5 for the line Y5 over here. And in order, just by doing so, we would just select the line Y5, okay, and that the data from the input would appear at the output of line Y5 respectively, while the other lines remain at their don't care state. So this is basically about the functioning and the internal logic diagram of the demultiplexer. If you all just are asked to construct the circuit of a demultiplexer by means of logic gates, then you all can just use this circuit as well, okay. So that just pretty much sums up our discussion on the functioning of the demultiplexers. And basically I would just like to mention that if we require higher numbers of demultiplexer, higher demultiplexer which have greater number of output lines than the ones available in the market, then we would require to cascade them. Let's say if we want to make a 1 to 32 demultiplexer, then the number of then this is generally not available in the market. The highest demultiplexer that's available in the market are the 1 to 16 demultiplexer. So in order to construct this demultiplexer, that is 1 to 32, we need to cascade two 1 to 16 demultiplexers, okay. So now the details about the cascading of the demultiplexers is obviously covered in our next tutorials on digital electronics, okay. So just keep in mind that this is also possible, and for the time being, I guess you all have gone through the tutorial quite well and have been able to understand about the functioning and working of the demultiplexer, okay. So that just sums up our discussion on the demultiplexers over here, and until then, it's just see you in our next tutorial on digital electronics, and till then it's just goodbye for now, and thank you.